This is a Math of Chem lesson for high schoolers. Let's begin. In this lesson, we will be going over balancing chemical equations, predicting products, mole ratio, formula mass, gram formula mass, mole conversion, percent compositions, and percent error. Here is some vocabulary to know. Chemical formulas use chemical symbols and numbers to show qualitative and quantitative information. They reveal the compositions of the substances. Chemical symbols. Each element has been assigned a symbol for its identification. Simple formulas. Certain elements can be found in nature in groups of more than one atom. Subscripts are used to indicate how many atoms are present in these groupings, which we call molecules. Molecular formula. Represents the makeup of a molecule of the substance. Indicates the kind and number of atoms each element needed to form the molecule. Empirical formula. The simplest ratios in which atoms combine to form a compound. Structural formula. Shows how the atoms are joined or connected to each other in a molecule. In a molecular to empirical formula conversion, the subscripts should be divided in order to generate their most simplest form. In C6H12O6, all the subscripts can be divided by 6. Doing this makes the empirical formula CH2O. Now we'll move on to balancing chemical equations. When balancing chemical equations, the first thing you should do is separate the products from the reactants with a line. Then list the number of elements on each side of the line. Change the coefficients of elements to balance the equation until there are the same number of elements on each side of the equation, and always remember to never change the subscripts. Here is an example problem. Try and figure it out before you move on to the next slide, which will reveal the answer. Moving on to the answer, as you can see, I've put a line dividing the reactants and the products. On the reactant side of the equation, there is one element of aluminum and 2 elements of oxygen. On the product side of the equation, there are 2 elements of aluminum and 3 elements of oxygen. Notice that if you put a 2 in front of the products, then the product side will have 4 elements of aluminum and 6 elements of oxygen. To make the number of elements on the reactant side equal to the number of elements on the product side, a coefficient of 4 should go in front of ALS, and a coefficient of 3 should go in front of diatomic oxygen gas. Doing this will mean that on each side of the equation there are 4 elements of aluminum and 6 elements of oxygen. Next is predicting products. First, we must determine which type of reaction is taking place. In a single replacement reaction, an uncombined element replaces another element that is part of a compound. In a double replacement reaction, 2 elements in different compounds replace each other. In a direct combustion reaction or a synthesis reaction, the combination of 2 or more elements. In a combustion reaction, oxygen combines with another compound to form heat and light, and oxygen acts as a reactant. It is exothermic because it produces heat. In a neutralization reaction, a special kind of double replacement reaction, it takes place when an acid and base react with each other. In a decomposition reaction, the breakdown of a single reactant into 2 or more products. What will the products of this chemical reaction be? Fe plus PbNO3. This looks like a single replacement reaction because Fe can replace Pb since Fe is an uncombined element and Pb is an element that is part of a compound. Making this a single replacement reaction would make it Fe plus PbNO3 yields Pb plus FeNO3. Moving on to mole ratios. Mole ratio questions look like, how many moles of blank are needed to produce blank moles of blank? When looking at these questions, write out how many moles of each element/compound there are. Here is an example problem. Then, once you've written it out, use math and logic to determine how many moles of oxygen are needed to produce 6 moles of iron 3 oxide. Looking at the same problem from the previous slide, how many moles of oxygen are needed to produce 6 moles of iron 3 oxide? So if 3 moles of oxygen produce 2 moles of iron 3 oxide, and we want 6 moles of iron 3 oxide, then both the number of moles of oxygen and iron 3 oxide should be multiplied by 3. Doing 2 times 3 will equal 6, and then 3 times 3 equals 9. So this means that 9 moles of oxygen are needed to produce 6 moles of iron 3 oxide. Formula mass. The sum of the atomic masses in the molecule and you round the atomic masses to the nearest tenth. Here's a sample question. What is the formula mass of C6H12O6? You can find mass in the upper right corner of the elements on the periodic table. It's easier to solve the problem if you organize it into 3 columns: given, mass, and multiply. In the given column, we have our given element, then we list the mass of the element in grams, and we multiply it to get U, which is the atomic mass unit. After finding out how much each element weighs and multiplying it accordingly, the weights should be added up in order to generate formula mass. Carbon has a mass of 12 grams, and since there are 6 carbon atoms, its mass is 72U. There are 12 elements of H, which weighs 1 gram, so that means there's 12U of H. Oxygen has a mass of 16 grams, and 6 times 16 equals 96U. 72U plus 12U plus 96U equals 180U. The formula mass of C6H12O6 is 180U. Gram formula mass is exactly the same as formula mass, but instead of being in the unit U, the unit is grams per mole, or G/mol. So given the same question as before, what is the gram formula mass of C6H12O6? The steps are exactly the same, but once you multiply it, you still keep the unit as grams, and once everything is added, it becomes grams per mole. Mole conversions. The formula for mole conversions is number of moles equals given mass divided by the gram formula mass. Here is our sample problem. 25 grams of NaCl. Na is 23 grams. Cl is 35 grams. 23 grams plus 35.5 grams equals 58.5 grams. The number of moles equals 25 grams divided by 58.5 grams per mole. To do the math, that means the number of moles equals 0.427 moles of NaCl. Percent composition. Percent composition by mass equals mass of part divided by mass of whole times 100. Here's a sample question. What is the percent by mass of magnesium in magnesium oxide? Magnesium oxide is MgO. Magnesium has a mass of 24.3 grams, and oxygen has a mass of 16 grams. So to set up the problem, it'll be 24.3 divided by 24.3 plus 16 times 100. Once you do the math, the percent composition by mass equals 60.3%. Percent error. Percent error equals the absolute value of the measured value minus the accepted value divided by the accepted value times 100. Calculate the percent error of the following experiment, where the measured value is 25% and the accepted value is 40.8%. This will be set up as the absolute value of 25% minus 40.8% divided by 40.8% times 100. Once you do the math, you will find that percent error equals 38.73%.